Well, no, well, by the same people, yes. They were the only people that did that experiment. But they actually, in the selenium one, they actually tried various substances. They tried arsenic, selenium, and a few other things. I forget exactly which ones, but some of the I forget what's the mineral that appears above or below selenium in the periodic table? Anyone know offhand?
Below germanium.
Germanium. I think they gave germanium to them, and that also extended lifespan as well. But I would think that's simply because they're chemically very similar. So some said that violates what I said earlier about one element not substitute for another. There is chemically that can happen to some extent. Sulfur is similar to selenium. What you find is selenium replaces sulfur in some molecules.
These blind exams?
Well, these are on animals.
Yes. No, well, I'm obviously not double.
Yeah, they're not double blind.
Just the experiment and no.
Well, that would be triple blind, wouldn't it? I think. I would think not. I think triple blindness is only a concept that's come in more recently. So they wouldn't be triple blind. Triple blind is where the experimenters themselves don't know what the hypothesis is being tested, or where the statisticians don't know what it is when they analyse the data. Double blindness is when the people receiving the treatment don't know whether they're going to receive it or not.
So are these amounts that the
So,
rodents could get from diet alone?
That's the amount of lifespan extension.
Yeah, so the amounts that are not listed there, the amounts that they were giving rodents, so for instance selenium,
Yeah.
are those amounts that one could expect the rodents to take from diet alone?
No, these are much higher than you get from your diet. In fact, the selenium was so high, it was bordering on toxicity, which is why I think the mean lifespan extension is less than the maximum lifespan extension. Whereas some of the animals did very well on it. No doubt other ones were damaged by it. In some experiments, they had a shortened lifespan. Depends also on the form of selenium that you're given. The selenium compounds differ in their activity from each other.
I just wonder with supplementing with metals,
Yeah.
whether the effect might actually be, I mean, it's off the top of my head now, it's occurred to me, that rather than actually you fulfilling some need for that particular metal, that metal might be dislodging another metal, which is actually having a toxic inhibitory effect.
Well, I suppose it's theoretically possible. I think it's pretty unlikely, but yes, it's possible. But if that's true, it's still a reason to take the supplement. Yeah.
Well, if that was the case, it'd be sort of more like rather than like sustained, taking it in a sustained way, more kind of a washout sort of dose.
So you could take some chelation treatment and get
I'm just wondering if these studies could differentiate something like that.
I mean, you can never be sure about the models in biology because people can just make up stories. But the idea with selenium is that, yeah, exactly. But the idea with selenium, I think, is that it is actually required for some enzymes.
Yes.
So I don't think it's knocking out molecules that they're already related.
Well, obviously we're living in a toxic environment now.
I mean,
metals and things. But if the body, our bodies, these rats' bodies could be saturated in something that's taking the physiological space of the selenium.
Can I ask a question? If it had that result, why haven't they done the experiment over and over again?
Well, for the selenium, because they were only interested in toxicity. They weren't interested in lifespan. They were looking for things that would kill animals.
Yeah, but presumably there are other people especially interested. I mean,
Well,
I know you said there are difficulties with experiments, but even so, it's quite a surprise.
It is amazing. I just don't understand it myself. I mean, you read literature and you think, my God, why haven't people rushed out to repeat the experiment? But, people don't. It baffles me. I simply have no idea.
So because this was done in the 60s, you would think that there would be the odd, there would be a lot of people following this, would be very excited by
You would think they would.
You would think that you would have the odd outlier of person who's taken their selenium over the last 50 years that would be living to 130.
Well, that is possible. There must have been some people must have read it and must have been influenced by it. But the trouble is, of course, we won't know for a long time. I mean, even
this is already 50 years ago.
Yeah.
Right?
But I think most people are only receptive to new ideas in their youth. So I would guess that people that have changed their diet as a result of these experiments were probably relatively young. So that if they are taking this, they're not going to start busting the 120-year barrier or even the 110 or 100-year some centenarians do take supplements, but I've not seen a sort of study that looks at all the data and pulls it together. It is some sort of very complicated meta-analysis, and it will be fraught with gathering bias.
And I thought it would be a fantastic source of data in supplement company or supplement provider companies' customer databases. Yeah, if you've had a selenium customer for the last 30, 50 years, or a base.
But then, you know, I mean, everyone will start saying, oh, there's commercial conflict of interest, you know, things like that.
There is, of course, one reason that the supplements sell quite well without having terribly good evidence. So
They
you
do.
don't
That's
need to
true.
do much
That's
research
true.
in order to sell a selenium
Yes.
supplement. So the companies are pretty happy. People kind of know that it's good for them, so no need to actually improve anything or figure out whether it's actually working.
It's true, because most members of the public, they're not interested in scientific proof before they buy a product, I think.
But companies do compete with each other in terms of how they produce vitamins and minerals. Like
Yes.
with minerals, for example, solder, they keep saying that it must be chelated. If it's not chelated, it does not work. It must be bound to protein in order to reach your cells, otherwise it will not. And other companies use
I know
the true food method.
Sorry, they use the,
True food method?
I don't know that one.
It means that the vitamins and minerals are derived from food, and they attach the molecules to the yeast, and so the body will recognize it.
So like with
and
chromium, you get GTF factor yeast, don't you, I think, and yeast-derived stuff.
yeah, so
rather
it
than
will be absorbed much better in the body.
Right. I think that's undoubtedly true in some, for some things.
The trouble is that these companies can profit by inventing a process that seems clever and scientific
Yes.
without having evidence,
Yes.
and worse, that they really don't want to get the evidence because there is a significant possibility they might get a negative result.
I'm sure that's true as well. Yes, I'm sure that's true as well. But just to go back to your point about the absorption, I mean, if it's true that you need it in special forms to get maximum absorption, then I would say, well, just take more of the elemental stuff. I mean, it's
but
fairly cheap.
The point is that the cell walls, they protect it. The only thing which can penetrate the cell walls is protein.
Yeah, so
So
you need.
if a mineral, if magnesium, for example, is not chelated, it will never reach the cell. It will be in your blood, but not in your cells.
But you have the pores and enzymes picking it up across the cell.
Yeah, that's right. I mean,
We don't want to perforate your cell.
It's true. I mean, B12 is a good example. We have specific carrier mechanisms to absorb vitamin B12. If you lack, some people genetically lack those mechanisms, and they cannot absorb B12 except not actively, but they can still absorb it passively. So it means they have to take more B12 to get the same effect. And I think the same would apply to other things as well. I mean, as you say, we do have a lot of molecules, a lot of the pathways do transport the molecules around. So I think you can probably passively absorb a lot of stuff from your gut just by taking larger amounts.
Shall we run through the last few slides?
Yes.
And then
What are we doing? Are we going? Okay, yep. We are near the end anyway.
Because you went back a long way after.
I did, didn't I? So let's that. Some fingers, yeah, this one, yeah. So the next one, so just go back 3 slides, I think. This is just looking at the reasons why I think this is ignored. We looked at the claim that it's poor experimental design, reducing the lifespan of control. So the next one is the same way. Biology is very complex, and you develop, you've got feedback mechanisms, you develop tolerances to the higher intakes, so basically you're wasting your money. So let's look at that one. So the claim is that we basically just excrete the stuff and we don't use it after a while. So initially you take the higher amounts of something, you start to use it, and then the feedback kicks in. And either we just dump the excess or we just burn it up inefficiently. And then when you stop taking it, you get a rebound effect, and you can sort of induce a deficiency of a normal diet. But there's